Alright, today's video is about 3D shapes, and we're going to talk about the names, how to name them, and then about their nets and their cross sections. Okay, a lot of little things to talk about. Okay, prisms are basically two types of 3D shapes, prism and pyramids. Prisms have to have two parallel bases that are congruent, okay? The sides of the shape are all parallelograms, and they're called lateral faces. Lateral just means the side. So when you have the prism, you can see the top and the bottom are parallel. For example, if you had something that was like this, if you had sort of a thing that looked like this would not be a prism because this right here is a little bit slanted and this one's going straight up and down. The shapes may be congruent when you meet them together, but they're not parallel. So they have to be parallel and congruent. Okay, so you don't like something like this. We call that, of course, a cylinder. Or you could call it a circular prism. Okay, so those are prisms. Pyramids have a base, have just one base. And that's usually a polygon of some sort, with a pentagon, hexagon, circle, some kind of polygon. And the sides, the lateral faces, are usually triangles because they come to a point. And you might want to put that in there. They come to a point, and that's what makes them a pyramid. Okay, they have to come to a point. Like if you have a triangular pyramid, it would be something that would come to a point. And see, the sides are all triangles, and so in this case, the base is as well. If you had a square one, then they would all come to a point, and the base would be square, but the sides would all be triangles. Okay, we've done a lot of this in class, and we'll continue to do this. This kind of lesson is really geared very much hands-on, and you have to almost have it hands-on to really understand it. So we'll have a lot of examples and a lot of practical things to do in class. Okay, the face, first of all, I'm sorry, prisms and pyramids are both named by their bases, okay? Like you would call this, the base of this is a circle, so the technical definition of this really would be circular prism. We just have called it cylinder through the years. This would be a triangular pyramid because the bottom is a triangle. This is a square or a rectangle, depending upon if you measured it and all that. But this would be a square pyramid or rectangular pyramid. Okay, they have three parts. Most of them do. The first part is a face. The face is the flat surface. It's the two-dimensional surface of a 3D shape, okay? Like this cylinder, the top, the two bases are your flat surface. The edges are where it's a line segment, so it's one-dimensional because it's just a length. It's a line segment where two faces meet, okay? Like in this pyramid thing, this pyramid right here, where this side triangle meets that triangular bottom or this square base, and that's your edge. All right, and the vertex is where it's a point, so it's 0 dimension, and it's where 3 or more edges meet. Like up here, you have 4 edges meeting. 1, 2, 3, 4, and that's at the point for the pyramid. Okay, here there's 3 edges meeting, and on you go. But it's a point where the edges meet. And we'll have a lot of practice in class about naming them and counting the faces and the edges and all that. Okay, the next thing is the net. The net is a two-dimensional representation of a 3D shape. Okay, it's like when you recycle and you flatten it out, that's your net. Okay, so here's some examples. This is an example of a cube net. A cube has 6 sides, right? And as long as we have 6 squares, we're good. And if you fold this up, you can fold it up on the creases there, it will fold up into a cube. This is a cylinder. This is an example of a net of a cylinder. You have the 2 bases out here, and then it rolls up into a cylinder. This is a triangular prism. It has 5 faces, see those 5 shapes, and the triangles are the base, so they're the top and the bottom, and then this would just fold up into it. Now, is this a cube? Well, it's got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7 squares, so it's not a cube. But supposing I erased that 7th square. Is this still? No, it's not gonna become a cube because you don't have any you don't have any top or bottoms. These are just going to overlap into each other, so it will not be a cube. So the answer there is no. No. All right. Is this a triangular prism? Well, again, it wouldn't because these things would fold up, but there'd be no back and front. You just have a bottom there and a back and a front. So you would need to have extended either on each side, you could do it each side, or you could have it here where it's folded up and these things are on the end there. Okay, so this one's no, unless you do that. Now, what is this a net for? Well, this folds up into anything. Well, you have to think about it, but if you fold it up on this triangle, made all this, if this was your base and folded all these up, these would all come to a point. So yes, it would be a triangular pyramid because again, they come to the top. They come to a point at the top. Okay, we'll do more practice with that kind of stuff. Okay, last one. Cross sections. We'll do a lot of stuff with cross sections as well. A cross section is basically, it's a 2D slice of a 3D shape. And please note that it has to be just one slice, one direction. You can't be in the middle of a shape and then like change directions and make a squiggly thing. It's going to be one slice, okay? In general, you can make a slice parallel to the base, diagonal to the base, or perpendicular to the base. Okay, that's basically what we're going to be talking about. So I did a couple examples. And again, this is hard to see, so that's why we're going to do a lot of it in class. Okay, the purple is parallel to the base. This is a rectangular prism. So parallel to the base is just going to be a rectangle. If it's perpendicular to the base, it'll be a different kind of rectangle, a different shape, but it will still be a rectangle. If you do it diagonally, I just did it. There's lots of ways to do it diagonally, but one way is to go from the top two corners to the bottom two corners, and that would still be a rectangle. You could, and we will, you'll see that we'll take a slice that's diagonal right out of the corner, and in that case it's going to be a triangle. The two-dimensional slice that you get when you just cut a corner off would be a triangle. There's a way to get a trapezoid out of a cube for sure. I think you can still get out of a rectangular pyramid. You can get a trapezoid as well when you slice through. But the cylinder is very interesting too, so I thought I'd look at that for a little bit. If you cut it parallel to the base, it's going to be a circle, right? You pretty clearly see that. If you cut it perpendicular to the base, you're going to get a rectangle. And we'll show that in class in case you don't, I can't make a believer out of you with my wonderful picture. But then if you cut it perpendicular to the base, and not necessarily intersecting the base, but just perpendicular, you're going to get an oval. And we'll demonstrate that in class as well. So we'll do a lot more cross-sections like that, and we'll understand. We've got some computer technology things that we can show you that'll help you see it more clearly. But cross-sections are used, that's where your x-ray medical things, they're all done. They're cross-sections. You get cross-sections of the brain, that kind of thing. They're cross-sections. So it comes in handy a lot with medical issues. We'll talk more in class, okay, about all this.